Welcome to today's Software AG webcast titled, How to Use Containers with Adabas Natural. Today's webcast will be presented by Zvonimir Ivanetich, Senior Architect, Adabas Natural at Software AG. As we move through today's presentation, we invite you to submit any questions that you may have via the Q&A box, which is located on the bottom center of your webcast dashboard. We will address your questions at the end of today's program. In the event that we're not able to answer your question, your submission will be noted, and today's presenter will be back in touch with you as soon as possible. Additionally, our program is being recorded, and this program recording will be made available to you in an email that will be sent to you within approximately 24 hours. With that, it is now my pleasure to welcome Zvonimir Ivanetich.
So, thank you, Will. Let me welcome everybody in this call today, also from my side. It's my pleasure today to present you the third webinar of my series about Adabas Natural on the cloud. And our today's topic is about how to use containers with Adabas Natural. So my name is Zvonimir Ivanetich, as already mentioned, and I'm a senior architect in the Adabas Natural business unit. And here we have an overview about our webinar series. So I hope everybody joined my two previous webinars where we looked into the exploration of the whole journey about the cloud, and then my last one about lifting and shifting to the cloud of your choice with a special focus on distributed architectures. And yeah, I will take this as a prerequisite that you have seen them, as I will use some of the information there in our today's session as well. And today, the whole focus is about containers. And I think it is important to understand containerization, understand what Adabas Natural brings as value to this and how it works. And this will really be a deep dive today, as I have prepared a packed, I would say, full 1 hour session for you. And after today's webinar, there will be 2 additional webinars following, where we will then look into Kubernetes and what it is about. But because we are packed, let's start with our today's session. And let's first introduce again this picture and illustration here about DevOps and the modern IT platforms architecture. So we see on the left-hand side, the agile development that we think all customers should move into with Natural One and the Eclipse-based development environment with a DevOps approach connected to a Git repository. And then on the right-hand side, the modern application and IT architecture, where customers have the choice to operate on infrastructure on-premise, on a private cloud, but of course also on public cloud hyperscalers. And then we have the topics about virtualization and isolation. We looked into virtual machines. This was big topics of our previous webinars, where we saw how we can operate in virtual machines, how it looks in the cloud on the different AWS and Azure environments. And today we will start with the topic of containers, isolating applications, and see what are the benefits that are coming out of this. And therefore we need to start with the deployment models. A quick recap. Maybe the majority knows about that, but I still want to build up here the storyline to understand that we have traditional deployments that our customers are quite familiar with. It means application run on physical servers. There are no resource boundaries. There's no isolation between the applications that are running on this machine. This can then cause resource allocation issues. And one important topic, applications need to be installed. They are all installed on this machine, and these installations, configurations after many years needs to be tracked and monitored and administered. Then we have the virtualized deployments. Virtualized deployments that many of our customers are already running today. We saw them in the cloud. It means multiple virtual machines on a single physical server. We have these applications being isolated via the VMs, but on a virtualization on a hypervisor level of the whole hardware. Still, this allows to reduce hardware costs. We have better isolation, better utilization of the resources, and virtualization really gives us flexibility and scalability, as we can provision our components also there fast and efficient, back up the machines and replicate them. And now we are advancing these topics when it comes to container deployments. container deployments, as we can see, has now a more relaxed isolation. So they share the operating system. There is a container runtime, and on top of this container runtime, we have very lightweight containers that are running, that have everything inside they need, and they can start much faster. They are using their own CPU memory and process space, and what is important, they are decoupled from the underlying infrastructure on top of the OS. And this allows them to be portable. They are portable across different operating system distributions, and they are in particular portable across cloud vendors. And this is a big strength of the containerization technology. So once again, a view into what a container is, or a container image. We see a small illustration on the right-hand side about containers. And you take all the functionality that you need and put it inside a container. So you get a lightweight standalone executable package of your software that includes everything it needs to run. And we have the code, the runtime, the system tools, the libraries, and the setting. And everything is based on a base image. That doesn't mean that there are any processes of the operating system running, but the base image gives you all the binaries that you need for operating functionality that you expect from an operating system of Linux. And we see this on the right-hand side. And now let's talk about the concept. With containers, there is no installation of products in a typical sense of your platform or your application. You have nodes, your machines, you have a container runtime on top, and then you have registries. You can have a private registry and you can have public registries like the Docker Hub that we will also see today. And inside the registries, you have your images. And these images are then simply executed. So you can just run these images on top of a container runtime, even if there is this image not available, it will be pulled out on demand out of the registry where it is requested from. And then it's operated on this machine and you can run this container. This gives you really a flexibility about deploying these components. And then of course the question is, where are these images coming from? They are built in a process. And this process we will also look into today, and I will showcase you in the live demos how we are building Adabas Natural containers that can be used in your enterprise. As a starting point, we will look into the Adabas Natural Community Edition for Docker. Probably you heard of it, probably you tried it. The Community Edition for Docker is something that we have created for our customers to achieve two things. We want to give the customers the ability to learn and get in touch with this new technology, especially in combination with Adabas Natural. Additional to it, it is an easy setup for new people in this area to get an Adabas Natural environment running and even practice approaches with DevOps that you can set up for your development process. And we will see these steps more or less today as it's really quickly up. You need to install a Docker Community Edition on a machine where no other products are installed. You usually have to register to the Docker Hub to be able to retrieve the images, and then you can just start the Adabas and Natural image containers as you like. And then you need, of course, the Eclipse-based Natural one, and you can run the demo application. And this can run on Windows 10 and it can run on Linux. And as said, only a Docker Community Edition is a prerequisite so that you're able to execute it. And there is no installation of Natural one or Natural in Adabas in the classical sense required anymore. So how does it look from an environment architecture? We see it here. This is what I will show to you. So we have the different components. We have on the left-hand side Natural one, an Eclipse-based environment with a local workspace. And then we have in the middle part here, the Natural in a Docker container with a Natural development server running inside, keeping the F user, the Natural nucleus. And I communicate with TCP/IP communication. And if I need a database, on the right-hand side, there's the Adabas database also running in the container and opening the new TCP/IP communication so that Natural can reach the Adabas database where it's running. And if you want administration, there is a REST server inside of the Adabas container of the Community Edition. And this REST server can be addressed by our new Adabas manager that is also running in a Docker container. And we will see exactly these components now in action. So to give you a first impression, about the capabilities that we have here in this environment. So let me start with my first demo for today. This is about Adabas Natural Community Edition for Docker. And therefore, I will start with a view on the Azure cloud. You probably noticed, we talked about this in the previous sessions. This is the portal. And here I have a Docker virtual machine because I want to show you the community edition running in a pure empty VM inside of the cloud, where I have just installed the Docker community edition. So we see I have a provisioned virtual machine, Adabas Docker VM. It's a Linux CentOS operating system running inside of a specific size. And I can reach this machine from outside. So, and now to connect to this machine, I can take my environment here and I will connect exactly with this machine via SSH. We see it's my natural Docker VM in the West Europe cloud, the one that we have just looked into, this Azure machine. So to give you an impression, this is really an environment where not really processes are running. It's quite plain, it's quite empty. There's nearly nothing on site, no server processes, but there is Docker installed on this machine. So if you have any VM anywhere and you want to operate, that is all you need to get started. So now if you ask yourself, where do I get the community editions from? So first of all, we have a page that is also linked, and this is the starting point about the Adabas Natural Community Edition for Docker. You can also recognize this picture here from my presentation. There is a getting started guide, and here you can download the additional part of it. And the getting started guide will explain you how you get to the Docker Hub page. The Docker Hub page is where we have our community edition Docker images published. And if you register there and sign for natural, for instance, if you search here for natural, for instance, but you need to type it right. There you go. And then you see there is a Software AG Natural Community Edition available that you can find. And this is what you have if you look into setup and strict instructions. So it's pretty simple to get started, as I can simply take this command here of the quick start that is in this document of getting started. I will explain it to you in detail what happens. So if you just take this command over here, move it into this environment, paste the command in there, you are already able to get started with the natural edition. So what does it mean? Docker run just starts a Docker container. If I say -D, I will put it in the background so that it's not blocking my interface. You need first to understand, if you haven't already experienced with containers, that containers are running isolated. So if you want to interact with the internals of this container, you need to create an interface. And the typical interface is the TCP IP port. So the 2700 port of the NDV server internally is now mapped to 2700 on my external port. And then we have to accept some enterprise user license agreements. And beside this, I have here a command so that I want to use an Adabas database and I need to be able to reach this database. So I have to put in my IP, and you will understand this later when the demo moves on. What does it mean? So I will take now exactly the IP address that we see here in my Azure portal and just put it there, as this is my internal IP address of this machine. I give it a name. And this is how the Docker runtime knows where to retrieve this image. And if it's not already on this machine, it would reach out to the Docker Hub. This is what the store means in front, and get the Software AG natural image. So in this case, I've preloaded it, that it doesn't take so long, but we will see with the Adabas one how it gets retrieved if it's not already on the machine. So now it's running. If we say Docker logs, natural community edition, we see that I have started a natural environment. We see here the buffer pool that is started, and we can also see the natural development server that is now available. So this is already a machine. So how do I interact with this internal machine? I can say here Docker PS, I see this machine, and I can also connect into this machine. So I can say Docker exec -it, say natural, and say bash. And if I do so, I'm inside of this container. Why I want to show this, I think there's one topic interesting. If I do a PS-CF, you can see the process list of this container. And you can see that there are only 3 processes more or less inside. The starting entry point shell that is awakening this container to life, and the NDV server that is running, and the T that is writing something to a file. But the interesting thing is, It starts with process ID 1. So this is the world, how it looks for the container. It thinks he is the only one who exists. He doesn't know anything about any additional container and any additional process that is running beside the ones that was started by this container. So what is the strength here? It is optimized inside of this container, but if you now look at the VM, the whole VM where it's running, so his host, and we look at the process list, you will see a lot of processes here. Even if this is probably the most lightweight VM that you can get on Azure, there are still a bunch of processes. Why there are processes? Even if this is a separate VM, they are there because they are created from the operating system, and it is simply an overhead of processes. Still, you can see something here, and that's interesting. These are the same processes that we could see inside of the Docker container. This means they are running natively and directly on the operating system. So there's no virtualization. It is executed absolutely efficient, as if these processes would run on the host directly. And this is exactly the case. And therefore, this shows you, I call it the soft features of containers. Yeah, the lightweightness of the container, still being isolated, but run idly on the host operating system without any emulation here. Okay, so this is the component. And now you could ask, okay, we have now the runtime that is available. How do we get in touch of it? So as I said on this page that we saw here, you can reach out to the Adabas and the Natural One Community Edition. And this is now a zip file that you can just download. And if you download and extract it, I put it here into temp, and then you get this folder. You can start it here with a link, and this is all you get. A really drilled down version of Natural One. For those who are not familiar, Natural One is our current standard development environment for Natural. And now I'm opening it up, and this is how it looks like if you select the workspace, and you can choose a Hello World application so that we have something to test and to demonstrate. So this is the Natural One development environment with my demo project here. And you see, I have no runtime. So I'm not connected to any runtime. And to get started with a runtime, I can now connect to the runtime that we have now created in the cloud in this community edition. So this is my runtime setting. And I will put here out, if I move here back to my VM, the DNS name that I also SSH connected to inside of this link. And the port was 2700, and we don't need any parameters. So now I'm connected with my just created community edition development environment of Natural in the cloud. And I can upload my modules. So I'm cataloging them, I'm sending them to this environment, and I'm ready to go. So it is a very simple application. Some of you probably know. And now I will start here my Hello World application. So if I execute this, what we now see is this simple Natural application being executed inside of this container. So to look into this, let's move to the container. And if I refresh here the process list, you see there's now one additional process running here. We're now looking at from the host perspective, but we could also move into the container and look into it. And this is how the world looks for the container. So this is my Natural process, the nucleus that was started now for this user that I'm connected here from my machine. So I'm working with this newly created environment inside of the cloud. Really nice. And now I have also a demo project that wants to retrieve a database access. So if you look into that, I will start this program as well. But of course, this will not work as there's only a Natural environment. So I'm getting a 3148 as my database 12 that is pre-configured, is not available. But that's fine. We will now create this database. We will just get a database from scratch from this environment. So how does this work? Let's take the other component. I said we have an Adabas Community Edition, and this is also available in the Docker app. So let's see, here's the description, the setup instructions. And if we move a little bit down, we have here also the quick start guide. So this is how to start it in the background. I can just copy that and put it here on the machine. So I will go outside because I'm running this on the host. I will clear it a little bit, and I will explain it to you as well. So I'm again starting Docker run -d. I'm mapping two ports. I'm mapping the port for the communication of the TCP/IP Adabas nucleus and the port of the REST server that is inside. We will also see this conceptually after in my architecture slide. And then I have again to accept the enterprise user license agreement. Even if this is a community edition, this is simply a legal topic that you agree that in general, this is a product that that has an enterprise user license agreement. And we will start Adabas database number 12, and I'm creating a database. So this is something we have created as a help. Probably you know this create database command. It's also available for the containers, and then on startup, it is automatically starting the demo database so that you can immediately get started with the employees data, for instance. So in this case, I promised if the image is not on this machine, you exactly see now what happens. So this image was not on this machine. There's only the Docker runtime. And now he identifies that it is not available locally, as we see it here. And now it is pulling this image out of the Docker hub. Yeah? And it is retrieving, it's extracting it. And after it is downloaded and extracted, we have the image ready, and it's immediately started as well. So here you see the strength. Yeah, how do you deploy, how products are deployed to a machine? And this is really a strength, because you can run all the images that you have available, doesn't matter if it's community edition or one you have built, simply on a machine and execute it. And you don't have to think about any installation anymore. So now the image is ready. Let's look into that. We can look into it with docs, logs, and here we see the Adabas database. So it's still starting. You see it says create demo database. It's still in the process of creating the demo database. And if I repeat this, after a couple of seconds, we now see that the administration interface is starting. This is the REST interface. And if I repeat it once more, probably this looks familiar to you. This is the startup of the Adabas database number 12 with its parameters. We see it's community edition, and we have opened TCP IP port 6001. So now the database is there. And okay, so, and now one more thing. Of course, you will be interested in how can this application reach my database when I'm communicating here. And here, I've missed something in the demo. So if I try to communicate now, I can explain this. We need a component. To communicate with the database, and this is the other TCP IP client. And when I started my Docker component just before, so you see, this is sometimes things that apply in the live demo. So I missed to, no, I did, just a second. I'm not sure. Let me just start this command here. I was thinking I probably missed the command, but let's see. Ah, there you go. Forget what I said, I did everything right with my starting command. So you see, the great thing is it works immediately out of the box. I even forget myself, I'm scrolling up a little bit, that I have put the IP address. You remember that I put it from the server. So this is what I need, because I need to specify where the IP address is for this machine. And this is what happened. So what we see right now is that I have a database. Yeah. So you see the steps. I have just specified the run command. It was not on the machine, it was downloaded, it created a database, and immediately I'm now able to operate with this database. And there you go. Yeah. So you say, I take another employee ID, and now we get number 6000. So that is, yeah, from my point of view, really amazing how you can get these components, these containers running on a machine. And now we will also get ourselves the Adabas manager. That's the other topic here. So I'm moving back to the Adabas manager. We also have it in the cloud available. We have a run command here as well. Let us start this as well to give you an impression how this works, so that we have the really full stack of the community edition running here. So now I'm starting the component as well. This one I have downloaded in advance so that it's ready. So let's see into the logs. We can look at PS, see if the component is running. There you go. So the Adabas manager is now starting a Tomcat application, and inside of this Tomcat application, you have the Adabas manager. And I can reach this now as well. So let's move back to my Azure platform, take the DNS name, and use the port that I have mapped. So let's take the port. And if you paid attention, the port was 8083. So let's see if it's already running. Still loading. Let's give him 2 seconds. Probably know that a Tomcat needs about 10 seconds to start, and then we have 10 more to unpack the package, and now it's ready. So you must imagine I have just there was nothing on this machine in the cloud, and I've just downloaded this Adabas Manager container. It was started, it's starting the Tomcat, it's deploying the web application of the Adabas Manager, and I'm ready to go. And now let's look into this as well. And now I'm logging into the Adabas Manager. You can do administration of entire network and the administration of the database. We will not look into the entire network topic. And after being on this machine, we need to specify a host. And for this host, I will say the connection name, I will call it Adabas Community, and I will put here the name of my VM in the cloud. And the port number here is 8190. And I can use the same credentials, and we have pre-configured this that it works smoothly so that you can just go with the same credentials when you connect to it. And if you look now here and open the info and we get the version, we know that it's fine. So we are now administering this Adabas instance that I have started with this web communication, with this web interface via the Adabas Manager. You see database number 12. Great, we can look into the database, here some topics, we can look into the user queue, yeah, and we can see some parameters. Yeah, I don't want to do a demo of this tool at all. It should just give you impression. We have this tool, probably you have already seen it, but here the focus is on how easy it runs as a container, yeah, with all its capabilities. And you can administer your Adabas database. One thing maybe is nice, if you look at the user queue, we see this is my user queue element. And if I move back to natural one, execute this application once again with the database access, yeah, and we start to get here an employee, we should see my user queue. Let's refresh it. There you go. Yeah, so we have my user queue here in this element. And if I stop this application here again, the user queue element will be on. So you see how this works. We have really a full monitoring. We saw the process that was started in the container. We see the user queue element in my Adabas database that's coming from my application. I think that's really nice. So this was an overview of the different components so that you get an impression about Natural, about Adabas, and all in the container. But of course, it's the community edition and it is pre-built. And now you could, of course, ask the question, okay, but how do I build my images? How do I get to this image? That's probably the tricky part. And now this is what we will talk about, because the next part is after the presentation of the community edition. Let's talk about the build approach for containers of ANN. That is probably as easy as we have seen to start the community edition. And I want to explain this to you so that afterwards, after you try the community edition, you can even immediately start and build your Adabas Natural images. The starting point that we have decided so far is that you need to start with a Software AG product master installation. So you have to take one machine where you usually install with your Software AG installer, and you should always apply the latest Zoom hotfixes on this machine. You can take a new machine, but you could even go with an existing development machine on Linux that you have, just create a dedicated folder and install into it. And you can use this folder with the products just for containerization. And what did we provide? We have provided assets to build the Docker images that we have structured by use cases. Because what is usually a question? If customer starts to think about container and they have this installation, they ask themselves, okay, I have my components, but what do I need to take out to get a container? What are really the components that I should put into the container? And this question we have solved, as we have provided a task script that extracts all these binaries that are required. And additional to this, we have, of course, a Docker file. The Docker file is the component that builds the images. It is the building plan. It describes from scratch what should be inside of this container from the first component. So it makes it a total scriptable thing that can always be repeated. And then we have additional files that are just required for Docker components, like start script to awake this to life. We saw this entry point shell when I looked into the processes in my natural container. We have config files and other required files. Why we have done this? We have standardized the process to build Adabas Natural container images. What we definitely don't want is customers all build different images on their own of all products. Still, it should be customizable. You can exchange components, especially for Natural. This is important to add additional components, but for all of the components, it could be necessary to exchange the base image if you want to, for instance, run a set of CentOS on a Red Hat UBI image. Still, it stays supportable because we have defined images and use cases, and it is trackable also for our support, but also for the customers, so that if there are changes to specific parts and you rebuild the image, you can identify what was done. And we stay flexible. We could even use older Docker versions, and because all this containerization is under heavy evolvement and improvement, we are also able to change our processes and use cases to adapt the customer needs. How does it look from the architecture? So we see it here. The same description, so you have the installed products, for instance, in the opt software AG folder, and then you have a product like Adabas, like Natural, or like NtireX, and then there is a subfolder Docker with the use cases inside. And there you have the script that will extract your binaries out of this installation, and then you have the additional files, like the Docker file, the start script configuration. And when you build it, then you get your images. You get images for Adabas, for Natural, for NtireX, and they can be directly put in a trusted registry. As we saw a pulling now in my demo, this would be such a registry where they are inside. And then you are able to execute it on any environment where the Docker engine is available. So just run and enjoy. Of course, we have created this process and distributed it into these components to also serve some more sophisticated requirements and needs for our customers in this process. As they will probably, or you will probably not build them just on one machine. You want to put these components in something that you can version more correctly. What does it mean? If you have these binary assets, like the Adabas tar, the extraction of Natural, you could take them and place them in a binary repository in your company. This could be something like JFrog or Nexus, if you are familiar with it. This is keeping binary artifactories. And then you can take your textual assets that are describing your build process, a start script configuration files, and put them in a source repository like Git. And this together can then end up in a continuous integration process, for instance, on Jenkins, that will build your image. But this is a continuous integration process that is not just building an application like Natural and putting it into an environment. It is really building the whole environment, the whole platform, the container with the operating system, with the platform and the application, and the result are the images then. And if you make changes to anything, to the Docker file, to your application, to the binaries, as you probably do an update, you have a new hotfix, you create a new binary, a new image is created. And then you are ready to go and deploy these images into your environment. You can apply here a blue-green deployment, exchanging existing containers with new rolling in containers into this environment. Let's look into two examples that we will concentrate today how to build images. And they are mapping the ones that you saw in the community edition as well. But let's look a little bit conceptually on it. The natural development container first. You see here more or less the same that you have seen in the community edition when I started the image. We have a natural development server container that is running, and inside there's an NDV server. The NDV server is started automatically, and the standard port is 2700. And then Natural is running inside. And Natural starts sessions based on NDV server and on behalf of Natural 1 requests. As you saw when in Natural 1, the front end, I've created a new session, we saw processes running. And you see also the several processes for different users would run inside one of these environments. And all of these processes are then sharing one buffer pool. The buffer pool is started automatically inside of the container. And one topic is also important to understand. When you work with containers, you will most probably also work with volume mounts. Because if you start a container, the components that are created inside or written to a file, they are not persisted. This means if you stop and remove this container, these components are gone. But this is probably not what you want for some of your parts. And if you look at the development server, this is the case for the F user, for instance. If you are working with an F user, you're uploading modules, as I did with Natural, and you're restarting the container, starting a new one, you want to continue with what you have uploaded to this F user. And this is absolutely possible, and therefore you are mounting volumes. Mounting volumes from persistent storages. And you see here how this is done. And we will see it in the demo afterwards. And beside of this, there are probably read-only mounts that you can apply. For instance, we are in the Enterprise Edition not putting any licenses inside of the container. So therefore, you need to mount them from outside. Alternatively, you can also bake them into the container. We will see this right now. But in general, you can mount them from outside, and the same applies to the configuration. Let's look into this. Let's now build a natural development container image. So instead of using the one on this environment, we will now build one locally. So let me clear this here a little bit. This was my connection to the cloud. I will take here a new window, and now I am on premise. Another example. I'm on premise on a VM, and on this VM, yeah, we are in the opt software AG folder. You see, I choose a folder 10.5. You could also create a separate folder and then install the products. And in this folder, we have the product installation. So I have the Adabas Manager, NTX, for instance, and Natural. So let's move into Natural. And inside these products, we now have these Docker folders. So this is what we have. And this Docker folder is the folder that keeps the use cases. As you can see here, we have prepared use cases that we think absolutely make sense for our customer to have, like use cases with app links, and in this case, or use cases with RPC services, and in this case, it's the natural development server use case. And now, if we look in this folder, these are the assets that I was talking about. You see there is a tar shell script that can be executed, and this shell tar script is creating these tar file. This is the extraction of the binaries that need to go into the container. Now, I have pre-executed this before the webinar because it takes more than a minute maybe, but there is nothing spectacular happening, so it makes no sense to wait for it. So it's there, and we can use it. So this is the first step. And now I will show you the Docker file so that you get an understanding what is a Docker file, how does it work. This is the Docker file. Let me scroll up a little bit. And the Docker file is building an image really from scratch. Yeah, and you can see all of it here. So it's coming from a base image. This is the CentOS base image I mentioned, CentOS 7. It has a label. It really creates the user. It sets the environment variables. You see here how this file is added into the container. Also these additional textual scripts. Here you see what I meant, that we give our customers flexibility. The licenses are usually not inside, but you could add them, your own licenses if you want. The same applies for the configuration files, but you can also mount them from outside. Both is possible. Otherwise, the container is just created with the standard configuration files. And we see an entry point, and also possible volume mounts are specified here. So this to give you an impression how this Docker file looks. But you usually, for starting, don't have to do anything on this, just to see, to understand what happens. Now the other topic is, I wanted to explain you, this is where I was struggling in the demo with the communication. How does it reach it? Where I was quickly unsure if I have specified the IP address. But probably you ask yourself why I added Adabas DB, or how is Natural reaching the database? And the magic happens in this DB mapping file. The DB mapping file is a part of the Adabas client, and you can specify here TCP IP communication for your database. And you see how it's configured. A specific database number is mapped to a specific DNS name that can be resolvable by your DNS server or by your host's local file or by any other configuration that you give, so that this can be resolved to name. And you see how it's reaching the 6001 part. And this is also pre-configured so that you are ready to go. And then we have a Readme file. The Readme file simply helps you starting. So you can cut the Readme file and execute this first command that will build this image. So you can start build. And now what happens? The steps that you saw in the Docker file are now simply executed. And the result of the steps that are executed will be my builded image. And this is more or less the same image that you have downloaded, or I have downloaded in the demo in the community edition. It is just the enterprise one. Yeah? And that's already it. The image is now ready. Yeah? You see successfully built. And if I say Docker images, we now see two images. One, the CentOS one, my base image, and the other one is the natural one that I just built 10 seconds ago. So this is by image. And now we can look into the Readme file to get it starting. And this command should already look familiar to you. Before I now start this command, I want to show you even something advanced. As I mentioned, these file mounts. So I've created here a folder that's called Adabas fuser. And if you look in this folder now, it's empty right now. I will mount this folder to be my persistent storage on this machine for the enterprise edition. So let's take this command, put it in here, say Docker run. I will put it also in the background. This time I'm mounting port 2799. The rest is fine. As it's the community edition, I have to mount the licenses. The licenses on this machine are 10.5 common config. And you can just mount it to the licenses folder. And now the trick with the folder that I have added, I will mount an additional one, this one. Yeah. And I will put it, probably all of you knows, it's opt, software AG, natural, and I need to make sure that I don't do a typo now, fuser. There you go. And I'm starting it. So now I have built this image really from scratch after the master installation here. I have configured it and I'm starting this image. If we now look into the log files, we see again, it looks similar like community edition. The buffer pool is started. The environment is ready to go. I mean, really cool. And now I will move to my environment over here. And instead of using the one in the cloud that I'm provisioned, I will now switch this environment and use the local one. The name of my VM is Docker1. And the port this time is 299 as I changed the port. It looks good. What we need additionally, this is not a community edition. The community edition, some parameters are predefined. For the enterprise edition, nothing is predefined. So you have to go like things, web UI, web IO on, or my UDB. In this case, it's 11. I want to specify it so that I can reach the database. Applying close. And now I can upload these modules. So I will now upload these modules to this environment. What does it now mean? Now you can see what happens. I will switch back to this machine. You remember I'm here in the fuser folder. And now you see there is a file. This is the library. Because I have mounted this internal folder inside of the container, the fuser of the natural, to this external one on my host. And now the container thinks when he's operating with the internal one, he doesn't know that he's mounted outside. But he's now persisting his data to this external component. Yeah, and so even if I would stop this container, build a new, mount another one, they would operate with this persistent data. And this is how the technique works, so that you can understand what interfaces for containers mean. And the most two used interfaces are the TCP IP ports to map with the outside world and the folders to map with the outside world. And all the rest is inside of the container. So now I can go. I'm back in Natural One, I can start, and now I'm executing in this machine. And this time I'm running locally. Yeah, so this is not locally in this Docker VM. It's in my on-premise Docker, the one not in the cloud, the one we have just now created in this process. Yeah, and you see it works on this environment here as well. Really nice. So we can also look here with the PS, and we can also connect to this environment. And now we will create us a database number 11. But before we do that, let's look into the database from a conceptual perspective. So this was the demo about how to build a natural development container. And now we will look into Adabas. So we also have an Adabas container, Adabas administration, and a detail view. And we see how it looks here. So Adabas is running the database nucleus. It is a point-to-point access through ADA TCP interface. And we have the standard port 60001. In the administration version, so we have two use cases here. In the administration version, we have a REST server. And the REST server is used for administration. You saw it in my community edition demo, and the standard port is 8190. And as I mentioned, the data files like ESO data work should be mounted persistent storage volume. And here we have two folders. The typical one to mount is simply the data for Adabas, that it's clear you want to persist data. But even for Adabas, it could make sense to have the data inside of the container. If you imagine, for instance, use cases where you need a test database, where you always want to start from the same test information, test data level, then you can always start the same container with the same data, execute your test, and just throw it away. But usually on production, on somewhere, this makes no sense. So therefore, you need to persist it. And this is how it's done. And you can also apply your license to a license folder. The Adabas manager that we saw in the demo here again is a web that is based on Tomcat, an individual container, and it is running on the standard port 8183. You remember it when I addressed it in my web browser, and it can connect to one or multiple REST servers. You will see this as well. And he has also some config files like a user.txt if you want to use basic authentication, or the configuration file with the database connections. And they should also be mounted to a persistent storage. So now let's look into the demo about the Adabas container image. So now I'm building this one as well. And therefore, I'm moving into Software AG, Database, Docker folder. So this is how the concept lands. I clear this a little bit. And here we have the use case. We have only two. I said there's an Adabas. This is a plain Adabas for customers who say, I don't want a REST server in my container. That's absolutely fine. They don't have to. They can build a container just with the Adabas nucleus. The Adabas administration is the more comfortable one. And there you can build one including the REST server. And this is what we will do. Again, I have pre-built this script, so to save you a minute of time. And this is the script that is creating this file. And we have a Readme file here as well. And it makes it easy for you to get started. So we don't have to look into the Docker file. You already saw this in Natural. The concept should be clear. I can build the image. I'm now building this image. It's running through the Docker script that is pre-built. Usually you don't have to do anything for Adabas. Only if you are adding some additional components that sometimes can be required. But this is a more advanced topic that I will not cover today. And now the image is ready. So if we look into Docker images, we see there's my Adabas administration image. And if you look into the Readme file, we are now able to start it. So there you go. Adabas image, paste. And let me explain it as well. So I say Docker run. This time I put no -d so that we really see the flow. We accept the user license agreement. I will change the ID 11, just a second. And I will do something here as well for you. Let me just stop this quickly. Let me move again. I also created here a folder, Adabas, because I want to mount something. I wanted to see that as well. So this is the Adabas folder. It's empty right now. And if we get back to the command, so I will create database 11. Yeah, we are mapping port 60,000 outside. This is the TCP IP port of Adabas. This is the port of my REST server administration. And now I will also mount the volume. Yeah, and I will mount the volume of Adabas and here put the /data volume so that you really see the enterprise component working. And now this will be mounted to outside and the database will be created into this outside folder. So let's run this. And this time we can see really how it works. You see Adabas has created a database. You see Adabas is starting and you see the REST server being started. And now it says REST server up and running and the database was already started already here at this line. So it's working. Database 11 is there. And let's look into this folder. So here I am on the Adabas folder and what you see right now, you see the assets that was created and they are now mounted to the outside folder. So they are no longer in the container, they are now outside. And if I would create another container mounted to the same, it would continue to operate with this database and with all the data that is persisted. So this is how the concept works with this mounting. And now if I move back here to my environment, I can stop this program and also use the database. Now, I'm communicating with my natural environment that is on-premise in this VM and it works. It is connecting now to the Adabas that I have just created from scratch in this master installation and started. So we get Marie Skidde, here's some employee demo information, or another guy, Daniel Lux, that we are running. So I think that is pretty cool how it works. And let's complete it with the Adabas manager. So I can now take my Adabas manager and I can add another host. So let me take my local one. I will now say Adabas Enterprise and the local one was Docker VM and this works as the communication is happening from the web application directly to my on-premise environment. The port is the same component at the host. And now I have added my Enterprise edition on my machine. Let's check if it works. Looks good, version 6.7. And now I have two databases. You see I have database 12, I have database 11. So this shows you how you can administer with one Adabas manager that you are running on a container multiple database wherever you have them, in the cloud or in premise. So what you see right now is a hybrid management of these databases. And you can again look into the parameters, into the properties, into the user queue. And here I can do the same game. So to really see if I'm operating here with my application, I can start this component, retrieve the data from my database, switch back, refresh this list, and we see there's another user queue element. This is the one that we are using. And if you are asking yourself where these IDs are coming from, we can look into the Adabas container. Let's do the following. We can say Docker execute IT. I forgot the name. This one, I have not specified the name. So my Adabas container got the fancy name. It's called Booman. Docker exec -it. It's called cool Booman bash. And this also to answer questions of people in the call, can I administer my database? Of course you can. Yeah, you can say other rep, I'm now inside here of the database, other rep db11 and say some. And what you get, administration, all the utilities that you are familiar in your enterprise edition are available in the container as well. So I'm here at this machine. And as I said, if you ask yourself where the name is coming from, you even, these are the names that you have here in front. They are that funny. And the client name that we saw is the one from the natural application. So if you look, if you communicate, if you connect into the NDV server with our bash and we look into the host name, you see it's the ECA. And if you now move back to this environment, it's the ECA. So just to show you how you find the host name that is connecting, and this is my natural application. So really to give you a comprehensive view on all of these components. And I know that was now a lot and I consumed a lot of time, but I think this is really interesting to see and to have this as a comprehensive presentation to understand these strengths of the containers. Okay, so and we looked into two topics, the Adabas and the natural development environment, but there are of course also others. Here's a selected view of them. I will not go into them today as we are probably at the end of our today's time. But I just want to mention there's also a natural online part that we saw in our presentations, an online part for app links. We have also an online part for the natural for Ajax components, that is the web IO running inside, depending on what type of applications our customer have today. And we have an approach how to build the corresponding web container. We also have the services part that we saw in my previous demos with this fancy natural cruises application that was accessing the service. And here we have also two components that can be built for a container. And these online and services, we will see in the next presentations, in the next sessions. I will show them running in advanced orchestration engines in container, in Kubernetes and how this operated. And of course, the Adabas SQL gateway plays a role as well. If customer want to access the Adabas data based on ODBC or JDBC communication, our Connex component can be containerized as well and put into the architecture. Here, a nearly final statement, Kubernetes. I will not talk about this, but what should give you the today's day as impression is there are several components, containers that operate on different machines. And you need a framework that allows you to really run resilient, distributed containers and architectures on an enterprise grade. And this is what Kubernetes is requested for. It gives you the capabilities that are listed here. I will not read them, but I want to encourage you to join my next session that will come in 4 weeks. And in this session, I will explain you how we bring these things together. Containers, cloud, and explain what Kubernetes is. And having said this, I'm at my final slide for today's webinar. The 3 key takeaways that I hope you could take at least about the topic of Adabas Natural and containers. If you have a cloud strategy in your company, Adabas Natural can be part of this journey. And you can re-architect your Adabas applications to really leverage all these advanced benefits of containers. And as always, if you want to learn more about this, I would encourage you to register for our upcoming webinars after 4 weeks of summer break here in Europe for me. So, and thank you very much for your attendance. I hope this was interesting, and thank you. With that, I'm giving back to Will for the question and answer session.
Oh, great, Zvonimir, that was fabulous. Thank you. So let's get into our questions. The first that I have, how would you transition an existing complex environment with multiple fusers, NatParms, databases, and SAG products to containers?
Okay, that's not a too easy one. So first of all, I think I cannot answer it with a couple of questions in this session, but we could take this up afterwards. So what I would say on this is, today most workloads are running on one single box on some customers with all these different components. And here you really get the ability to distribute these different applications and components, your databases and your natural parts on different machines, to put them in containers and really achieve here some isolation. But of course, if it is a complex application, it will require you to get an overview of your application and understand how you can take the different parts into the containers they belong to. But you definitely have the chances to do that, and it is worth it. Okay.
Okay, fabulous. We'll pass that questioner's information along to you, Zvonimir, as well. Yeah. The next question, is it possible to build one big container containing all components?
Of course, possible it is, but this is definitely not recommendable, because as you have seen today, containers are meant to serve their purpose. They should focus on its task, and therefore, as we saw the use cases today, every container should only contain isolatedly the libraries, the components that he really needs. And we are giving all the assets that customer require to build these isolated components. And then you really get the strength of isolation, the strength of resiliency of these components. You can deploy them independently, update them independently, and this is a real strength. Therefore, the answer is it should never be in one big container.
Okay, we have just a short window, so I'm going to pose you a question, and if you think it's too long an answer, let us know and we'll make sure that we can get back to the questioner directly. But the question is as follows: how do I make sure that ANN can be migrated non-disruptively from on-prem to cloud or with minimum downtime? If the database is huge, what should the strategy be?
Yeah. So as you probably thought, Will, this is not easy to answer. This is a topic about the migration strategy that should be applied via a project. And this depends. There are different strategies how the data can be moved from one environment to the other. And depending on the specific customer situation, this needs to be defined mostly in an assessment how this approach can be done, leveraging the tools that are existing to also have some kind of data migration that is incrementally updating the data on the cloud.
Okay,
but we should take this also offline, and we can catch up with the people to give them a more comprehensive answer on that.
Okay, so to those questioners, we're going to be sure that your information gets passed along to Zvonimir, and he'll be back in touch. So that all been said, as Zvonimir did indicate, we are in the middle of what has been and will continue to be a very exciting Adabas and Natural themed program. So we want you to continue to join us. You can schedule and look at these programs by visiting softwareag.com, and you can look under the events section, which is located under the About Software AG tab, to register these programs. A very warm thank you to all of our guests that have taken time from their day to be with us. Zvonimir, of course, a very warm thank you to you for your time and what was a very informative and fun program to watch. Our program has now ended, so I do hope the rest of you enjoy your day.
Thanks, everyone. Bye.